What's going on, everybody? Chris here, back with your second episode of Learning R with Chris. On today's episode, we're going to talk about some data structures and data types in R, which are fundamental for storing anything in R. It's kind of like how R interprets the things that you're putting into it. So the first thing I'll go over is the mode function. So this will tell you the type of the thing that you put in the mode function. So if I put a string of characters in here, R is going to give me back that whatever you put in here, that's of type character. And the type character just means like one or more characters surrounded in quotes. Then we can also check the mode of something like a number. So the mode of 1 is of type numeric. It's actually going to be type numeric even if we have decimals at the end as well. And lastly, we also have logical values like true and false. So things are will be of type logical if it's like binary, like it'll either be a yes or no, right? So something like 4 less than 5, that's going to evaluate to either true or false. And as you might expect, that's going to evaluate to true, and it's of type logical. All right, now that we got the data types out of the way, we'll go down to vectors. So vectors are pretty important in R. They're basically just kind of like a list of elements put simply. So if we want to make a vector, then you just, this is our little assignment operator here. So we say we want X to be this vector. This C function stands for combine, and it's how you make vectors. We can say, just make a simple vector here, 1 through 4. And up here you can see our vector X. It's of type numeric, and it has 1, 2, 3, 4 in there. And then, hold on, let me just, I can clear all this stuff in my environment out for you guys. There we go, that should be more clear for you guys. So we have X, 1, 2, 3, 4. So some natural things you might want to do with vectors is access the elements inside. So if you want to get to the second element, you say X and then these square brackets, and then you put the index that you want to access. So if I want to access the second element, I put X at 2 is kind of how you can read that. And of course it'll give me 2. You could even do like arithmetic here if you wanted to. So you could do like X at 2 plus 1, that's like X at 3, so obviously that's going to give you 3. And I guess this is a little confusing because I named like the vector 1, 2, 3, 4, so it doesn't actually give you like the same number, right? So if I did X is 4, 5, 6, 7, and then I said X at 2, then that's going to give you 5 because it's the second element. Also, you can do operations between vectors as well. So if I make a second vector, let's say, go back to my trusty 1, 2, 3, 4, and if you wanted to add these two, you can do that for sure. And this will add each, like element-wise, each of the elements of the array. So 4 plus 1, 5, 5 plus 2, 7, for each element of the vector. You could even do like, if you just did like X plus 5, for example, that'll add 5 to each element of X. You could do X times Y, and similarly this will also do like element wise, so 4 times 1, 5 times 2. But if you wanted to do like the matrix multiplication of the two vectors, then you'd have to surround the asterisks with percent symbols. So like that. Sorry, that's not clear. That should all be on the same line. Like that. If you're not familiar what matrix multiplication is, don't worry about it. It's just for those of you that do. Also, I should mention that vectors always have to have the same type on the inside. So like if I say mode of X, it's of numeric because everything in X is numeric. You can't really have more than one mode of thing in the vector. So for example, if I try to make a new vector, z, and we will put, if you try to put like a logical value in there, as well as, I don't know, like some characters, R will let you do it, but if you look up here, it's of mode character, so it kind of like, it took your logical value and it turned it into a character. So if you look at like mode of z at 1, that's not logical, that's character there. So yeah, just be careful with that if you're ever using vectors. If you want to do something like this, a vector probably isn't what you want to use. We'll get to what you would want to use later, but for now, let's just move on to matrices. So first of all, just wanted to show you guys, if you do a 1 colon and then another number, it'll give you like 1 through 9 of like the natural numbers, like that. Yeah, you could even do like, yeah, 3 through 9, or like whatever you want to do. So I can make a matrix with the matrix function. It's named not very cleverly, but that's okay, makes it easy to remember. Then, so if I put 1 through 9 into this matrix maker function, that's going to give me a 9 by 1 matrix, so 9 rows, 1 column. And that's just the default. Obviously, you can take a look at the arguments of a function by doing that. Oops. Again, not clear because it's not on the same line, but yeah, if you put just like a function name inside of this args function, it'll tell you like what the arguments of the function are. So you see here it says by default, these are like the default values. So the first argument is going to be your data. So here I gave it like 1 through 9. Number of rows is going to be 1. Number of columns is going to be 1. We'll get to these later, but so we can see here that if we wanted to say like make like a square matrix, like a 3 by 3 matrix, then we could just say M is going to be a matrix. Our data is going to be 1 through 9. And then the number of rows, we're going to want it to be 3. We can also specify the number of columns. R is smart, so it would infer that by the number of rows, how many columns you want based on your number of elements, but we can be explicit too. So take a look at M here, and we see we have our 3 by 3 matrix. And you'll notice that it added column-wise. So the like 1 through 9 gives us obviously like 1, 2, 3, 4, 5, 6, 7, 8, 9. And it added as the first element, it goes like column-wise. So like 1, 2, 3, and then second column, 4, 5, 6, instead of row-wise. And that's what this this argument here means, like by row is equal to false by default. If you make that true, I guess I can show you guys that. So let's say by row is equal to true. Then you see we get the transpose, or like the opposite of that matrix there. So some things that you'd probably want to do with matrices: access the elements. So we could say M at 1 here, it's going to be 1, M at 4. So again, this is column-wise, right? So the first element is 1, second element is 4, third is 7, and fourth is 2, because it's going column-wise. If you wanted to be like explicit, then you could say like M at 3, 3, and this first one is the row, and this one is the column. So you're saying you want the third row and the third column, which is going to be a 9. You can also do things like take subsets of your matrix. So say you want like, I don't know, like this first little 2 by 2 square of your matrix. Then you'll take your matrix and you'll say, I want for the first row, I want the first and second rows, and for the columns, I want the first and the second column as well. And you see we successfully subsetted our matrix of the first, like the first little box here. So that's something useful. Some other notation for matrices: if you want say I wanted like the first 2 rows, but I wanted like all the columns. I didn't want the 2 by 2. I wanted all 3 columns. You can say that by saying, obviously, the first part's the same. You want the first and the second rows. And then if you just leave a comma here with nothing on the other side, this says I want all the columns. So yeah, that'll give you your 2 by 3 matrix subsetted from the original matrix M here. All right, so I guess we, similarly to vectors, we can do operations between matrices as well. So let's make a second matrix, call it my matrix, because I'm just as clever as R sometimes. And call our matrix function 1 through 6. And I don't know, let's make a 3-row matrix here. So that's what it looks like. So then we can do M times my matrix. So that doesn't work because it's trying to do it element-wise, but you can't really like do that because the number of elements doesn't match. But if you wanted to do like matrix multiplication, like with the vectors, then you just surround the times by percents again. And this should work because we have a 3 by 3 matrix and a 3 by 2 matrix. And it works. So that's how you do like matrix multiplication with matrices. All right, so I don't typically use matrices that much. Some people do. Oh, by the way, you can also look at how many dimensions your matrices are by doing that. So we have a 3 by 3. But yeah, a more useful data type, in my opinion, is lists. So let's take a look at those. So lists are kind of like vectors, but they don't have that constraint that each element has to be of the same type. So if we go back to like what I was doing earlier with assigning the vectors. So say instead of the vector function here, like the combine function, we made a list instead. So if we do this, take a look at Z here. Specifically, if we take a look at the first element of Z, that's true, as we'd expect, but the nice part is it retains its like logical mode. So R won't like try to coerce everything into being the same type here. You can have a long list and everything can be of different type, and R will not try to make them all the same type. So that's really nice. So to show that off, let's make a list here. So as you probably tell here, it's just again, how to make it, you just say list. And then you can also name the elements, which is often convenient. So say I want the first element's name is going to be number. And I'm number 1, obviously, so we're going to make it 1. Maybe I want an element called logic, and it'll be true. Our element vector, give it X. Very original names. And then maybe some characters. Wow, I'm learning so much R. Thanks, Chris. No problem, viewer. So we can do something like that. Let's take a look. And we can see we have 4 elements. They're all named, so that's what this notation means. So our first element's name is number, and it's got a value 1. And as you could tell by this, you could probably tell by this notation, you can access elements of lists by using the $sign. So my list $, and then RStudio is nice. It'll give you the different named elements here that we could pick from. So let's say we want our number, and that'll return 1. And so don't get confused. If you try to access a list using like array notation like this, it can be a little confusing, but this will always return a list. It won't, like the type of the thing that it returns is not what you probably think it is. So if you do that, you get like a list of size 1, and it keeps like the list form. So like if you tried to, I don't know, my list at 1 and you tried to like add 1, then that's like not going to work, right? Because you're trying to add 1 to a list. So if you're trying to like actually have a type, like get the type back of the thing that you're accessing, you can either do what I did up here, which is to use 2 square brackets. That'll kind of like unlist the thing that it returns, and then you can add 1. Or this $sign is equivalent to the double brackets, but of course the element would need to be named in that case. So you could say my list at number +1, and R will not yell at you if you do that either. So that's pretty much lists. Again, pretty convenient, especially if you need to store things of different types, and it's kind of an intuitive name for it too, if you think about it. Like if you think of like a shopping list, you might have a bunch of different stuff on there. Not everything's going to be the same type, and it's kind of messy and stuff like that. But you can actually do like crazy things like put lists inside of lists. So you could like put matrices inside of lists too. So you could say, if I go back here to when I declared my list, like I could put my matrix in there as well. And then starts to get a little ugly. If you can imagine, if you have lists inside of lists inside of lists with matrices, and it can get a bit hairy. So, but nonetheless, it's very powerful because of all the flexibility that it has. All right, so we've done a lot. Let's talk about a couple more things and then wrap up. So next one's a big one. We're going to talk about data frames. So data frames are basically, let's get Paint open for this one. This is a big one. So data frames, it's basically a list, but R is going to yell at you if things are not square. So in your list, you could have like matrices, and you could have like one number, you could have like logical value, like say like 2 logical values. And these, like, this is not a rectangle, right? Like, or it doesn't necessarily have to be one, like missing one here. Like this could be a long matrix. So basically that's the difference with data frames. It's going to force you to stay in like a square or a rectangle, sorry. So I guess we can play around with it a little bit. So let's make a data frame, call it shop data frame, and I'm going to be making a little shop here for you guys. So big difference here. There's a dot here. So you'd think that it would just be like this, but no. R has to be a little bit confusing. So it's going to add that dot here to make your data frame. So let's make our name of our first column is going to be item. And I don't know, let's get some carrots in there. Maybe a bananas and some chips. And then, so those are our items, and then maybe we'll have some price for those items. What's reasonable here? Let's say $2, $3, and $4.50. And maybe we'll have, just to get another data type in there, we'll have binary variable saying if your choice is healthy or not. So bananas will be healthy, or sorry, carrots will be healthy, bananas will be healthy, chips are not healthy. So barring any syntax errors, we should be able to instantiate that. As you can see, we got our shop data frame up there. And let's take a peek. That looks terrible. All right, we're back. Took me a sec to figure out what I did wrong instantiating that, but just a little syntax error here. I forgot to put a bracket around the C here, the first vector, and I got one too many on the end here. So if we instantiate that properly and then take a peek, then it's looking a bit better here. So you can see it's rectangular. Each column is representing like a variable, and then each row represents like an instance of data, right? So we have an item carrots, it has a price, and this binary variable if it's healthy or not. So that's like a glimpse into like what tidy data looks like. There's a couple other qualifications, but for now just keep in mind that your data should look rectangular. Each column should be like an attribute, and then each row should be like an instance of your data. So that's nice. So data frames are like, they work a lot like lists, right? So you index in with this $sign. Often your columns are named, so it's nice. You could just take a look at that, and you get a vector of logical values if you index in with that. But more interestingly, we're going to look at something called Tibbles, which is a part of the tidyverse package that I had you guys install earlier. So to attach packages, you're going to want to use this library call function, and then just put in tidyverse here. I already have it loaded in from earlier, but if you do that, it should give you some indication that you've attached some necessary packages. And then so basically the tidy version of the data frame is called a Tibble. So to look at your data as a Tibble, again, not very cleverly named, as .tibble, and then as your first argument you can put in your data frame. And then it's just a bit nicer, right? Like you can see that ours like type prediction here guessed that this is your item is some like factor variable, so it can take on like different types of values, and then this is a double, so it's like a decimal number, which is correct, you know, it's a price, and then we have a logical value, which is the thing healthy or not. So that's really nice. It also has, Tibbles have nicer printing properties. So if this table was a lot more complicated and had like 20 million rows, then if you decided to output this to this console, then you'd be sitting here for a while. But nicely, if you do like if you do this with a Tibble, it'll limit it to the first 10 values unless you otherwise indicate that you want to see the whole thing in gory detail. Yeah, so this is kind of how you get your data into R, and we'll be working mostly with Tibbles and with the tidyverse. And next time we'll probably look at some basic operations you can do, like, you know, how would I add another column onto this Tibble as a function of the other columns, or like, oh, how do I don't know, just how do I look for things that are only healthy and stuff like that, which are just essential database operations that'll help you work with your data nice and efficiently. So until then, this has been Chris, and see you guys in the next one.